So here we have a parabola with rational coefficients. Our goal is to actually graph this. And so the form that we're going to use to graph this parabola is y equals a times the quantity x minus h squared plus k. This form will actually give you the vertex. And the vertex is hk. So how do we get it into this form? We're going to use a technique called completing the square. Why don't we do that? So y equals, and what we're going to do is factor out a 1/4 from the first two terms. And so 1/4 times what will get you 1/2 x. So we need a 2x here. Now we're going to leave a space. We still have subtract 9/4. Now in that space we're going to complete the square. And the way we do that is we divide the coefficient of 2 here by 2, which is 1, and then we square that 1. But 1 squared is just 1. And then we put that 1 right here. Now, we just changed the value of the expression, which is very illegal. So we have to make sure that we do not change the value of this expression. So if you look very, very carefully, I actually added a 1/4. So to make sure we don't change the value of this expression, we're going to take away 1/4. So now the technique that took place was we completed the square and we added 0 on the right hand side of the equation. Okay, how do you know you added 0? Because 1/4 minus 1/4 here, 1/4 minus 1/4 is equal to 0. So we just added 0 to the right hand side or of the equal sign. Why don't we finish this problem? Y is equal to 1/4. You completed the square so that we get that nice quantity squared, and now we have minus 10/4. But minus 10/4 is just minus 5/2. Now we have the vertex. So the vertex is -1, -5/2. Now, why don't we actually graph the y-intercept? It's very easy to spot the y-intercept. The reason for that is because we already know the x-coordinate is 0. So when the x-coordinate is 0, y is -9/4. How do you see that? Well, there we go. We can actually see it right there. We're ready to graph this. So let's do our best to, if you have a ruler, take advantage of it. You know, it's much better to graph with straight lines. So let's draw the y-axis. Now my vertex is actually in quadrant 3, and this is opening up. So why don't we draw quadrant 3 a little bit lower? And there's my x-axis. Let's draw -1 and then -2 1/2. So maybe here that's -1, and then -2 1/2. So right here is the vertex. Now we have a y-intercept. It's 0 and then -2 1/4. 0 and -2 1/4. Oh, I'm actually in text mode all of a sudden. That was an accident. So the y-intercept's right here. And so it would be nice to draw another point that's symmetric to that. and we can label this point. That point is just simply -2, and it is what? -9/4. Let's play connect the dots. And we have a rough sketch of our parabola. There you go. Let's box the graphing form here. Might as well graph, box the vertex, box the y-intercept, and we need this point. This is sometimes called the symmetric point, symmetric to the y-intercept. Why do we call it a symmetric point? Because we also have the axis of symmetry here. The axis of symmetry here is the vertical line x equals -1. So you can see the symmetric point right there.